So we're looking at index laws as an introduction to logs and exponentials. Now, index laws are probably something that you've looked at in year 10, perhaps even year 9, but now they become more important because they will help us manipulate information so that we can graph. I guess the most important thing here that you need to come to terms with is the terminology that we use. So we're looking at this expression here, a to the n, where the a is the base, okay, a is the base, and the n is the exponent or the index. So a is always the base, it's always got to be non-zero, so it must be a whole number base, and n is called the index. So what are the index laws that we're looking at? Well, when you multiply two indices, you add the powers. When you divide two indices, you subtract the powers. When you multiply two powers together, then you can multiply them. When you have got two bases raised to the same power, you can split it up and raise them separately to that power. And then when you have two bases divided one into the other, raised to the same power, again you can split it up. Again, it's just to help us with the manipulation of all of this. So for every non-zero a positive integer n, a to the power of 0, a really unusual thing, isn't it? But anything to the power of 0 is always going to equal 1. So even if we had 100 to the power of 0, it equals 1. 50 to the power of 0 is equal to 1. This is handy, a to the power of negative n, so 1 over a to the power of n. To make a negative power positive, bring it down the bottom. If it's negative down the bottom, then if you bring it up the top, so in this case we're making it up the top over 1, that will make it a positive. And 0 to the power of 0 is undefined. So hopefully they are rules that you are familiar with. Let's have a look at some examples. So when you're asked to simplify expressions, start with the whole numbers and use the laws that you've always used for that. So we know that 3 times 4 is equal to 12. So now with your bases, a to the power of, and it's 2 plus 3 times b to the power of, 3 times 3 plus 3, beg your pardon. So it's 12 a to the power of 5, b to the power of 6. Of course, they get a little bit harder. So again, let's start off here. If we can follow some sort of system and not be messy about the whole thing, we can work through it. So with fractions, I'm going to deal with the whole numbers first. 8 goes into 8 once, goes into 16 twice. So up along the top now, I've got 2 times 4 is 8. So I'm going to do the top all together. A to the power of, so it's 5 plus 4, which is 9. And I have b to the power of, 1 plus 3 is 4. And then it's over a b. Now there's nothing to simplify down the bottom. I've simplified the top, the bottom is simplified. Now I can do the top and the bottom together. So that gives me the 8 stands alone, and now I've got division, so I'm going to subtract. So 9 take away 1 is 8, and 4 take away 1 is 3. So my suggestion is simplify any fractions you can in terms of the whole numbers, and then simplify the top of the expression, simplify the bottom of the expression, and then do both together. let's have a look at the next one. So remember, with this one, the rule says that you multiply the powers together. So it's going to be b to the power of 6 times b to the power of minus 2. We are multiplying the indices. They are the same base, so we're going to add them. So it's b to the power of 6 minus 2, which is 4. With D, get rid of your brackets first. So remember, everything inside that bracket is raised to that power. So I've got 2 to the power of 3, which is 8. A to the power of, now 2 times 3 is 6. We're multiplying the powers together. B to the power of 3 times 3, which is 9. Times, okay, again, this bracket will be raised to the power of negative 2. So what I might actually do here, instead of saying times, because it's to the power of negative 2, this could actually have been written as 2a squared b cubed over 3ab to the 4 squared, because when you bring the negative power down the bottom, then it becomes a positive. So now I can write this like this. So over, so 3 squared is 9, a to the power of 2 and b to the power of 8. Okay, I can't simplify the top any further. I can't simplify the bottom any further. I can't cancel down 8 and 9, so now I'm just going to do the top and the bottom together. So 8 over 9, 6 take away 2 is 4, so it's a to the power of 4 and b to the power of b to the power of 1. 9 take away 8. So really, if you just wanted to make it look a bit nicer, a to the 4 b over 9 is your final answer there. Okay, so the first thing we're going to do with these is make sure that we get rid of our square root sign. So it's 3 to the power of 1/4 times 6 to the power of 1/2 times 2 to the power of 1/4 over 16 to the power of 3/4. Now what we're hoping to do when we're simplifying this is reduce the amount of bases that we're using. So you can see that we've got a 3 and a 2. I don't think we're going to do anything better than having at least 2 bases. 6 can be broken up into 2 times 3, and 16 can be broken up into 2 to the power of 4. So I think there are bases that we're going to use. So it looks like this: 3 to the power of 1/4 times 3 times 2 to the power of 1/2 times 2 to the power of 1/4. 16 is 2 to the power of 4 to the power of 3/4. Now it's probably a good idea to have a little bit of a working out column over here so that we can do some of our fraction work. Alright, so let's keep going so that we don't put all our mess all in one spot. So I'm just going to tidy this up, and I've got 3 to the power of 1/4 times 3 to the power of 1/2 times 2 to the power of 1/2, 2 to the power of 1/4. Down the bottom, 4 times 3/4. The 4's cancel out, and I'm left with 3, so it's 2 to the power of 3. Alright, so because we're multiplying, we're going to add the powers. So we've got 1/4 plus 1/2. Hopefully we all know that common denominator of 4 there. So 1 plus 2 is 3/4. So we've got 3 to the power of 3/4 and times 2 to the power of 3/4 divided by 2 to the power of 3. So then we've got subtraction. So we've got 3/4 take away, and I'm going to write it as 3 on 1. again, I need a common denominator there of 4. So it's 3 minus 12 times by 4 at the bottom and the top, which makes it minus 9 on 4. And so we're left with 3 to the power of 3/4 times 2 to the power of minus 9 on 4. Usually the question asks you to write it with positive powers, so let's do that. 3 to the power of 3/4 divided by 2 to the power of 9 on 4. And that's a nice answer left that way. So lots of fractions, gentlemen. Make sure that you polish up on those fractions, otherwise you're going to struggle a little bit with not so much the indices, but just the addition and subtraction and multiplication of them. I'm going to do this one be exactly the same way. I'm going to start by getting rid of my square root signs. So 32 to the power of 1/4 times 12 to the power of 1/2 times 12 to the power of 1/3 all over 16 to the power of 1/4. Alright, trying to limit the amount of bases I've got here. So I'm going to say 32 is 2 to the power of 5 to the power of 1/4. 12 would be 3 times 4, and we know that 4 is 2 squared, so I might write it as 2 squared to the power of 1/2 times, again, 3 times 2 squared to the power of 1/3 all over, and again 16 is 2 to the power of 4. So what you can see there is that I am only using the bases 2 and 3. Now if you had a written 4 initially, so 3 times 4 is 12, you'd know that you could break that down further, so you don't have to do it all in the one hit if you're still practicing this. Let's multiply out here, so 2 to the power of 5 on 4 times 3 to the power of 1/2 times 2 to the power of 2 times 1/2 is 1, so we don't need to do anything there, times 3 to the power of 1/3 times 2 to the power of 2 times 1/3 is 2/3. And down the bottom, again multiplying, 4 times 1/4 is 1, so it's just 2 to the power of 1. Alright, we've got a lot of tidying up to do, don't we? So we're going to, let's put them together to make it a little bit easier. You've got 2 to the power of 5 on 4. So I'm going to do the top first, times 2 to the power of 1, times 2 to the power of 2/3, times 3 to the power of 1/2, times 3 to the power of 1/3, over 2. Let's come over to our working out column here, and I'm going to do 5 on 4 plus 1 plus 2 on 3. Common denominator there would be 12. So times by 3 would be 15 plus 12, and times by 4 is 8. 27 and 8 is 35 on 12. Let's just double check that. 35 on 12. Alright, so you've got 2 to the power of 35 on 12 times 3 to the power of, now you've got 1/2 plus 1/3 equals, so 6 is the common denominator, times by 3 times by 2 is 5 on 6, and divided by 2, and now we can do the 2's together. 1 would be, okay, you've got 35 on 12, take away 1, which is 12 on 12, which makes it 23 on 12. So therefore my final answer 2 to the power of 23 over 12 times 3 to the power of 5 on 6. Even more so with that one, the fractions are the bits that you're going to have to be really careful with. Please, please, please have a working out column so that you're not putting it all in one bit, and don't go guessing. Make sure that you are working them out properly. So that hopefully will get you going with exercise 13A and 13B.